Now, we are going to discuss about the non-aqueous solvents. A solvent is a chemical substance which is used for dissolving a solute to get a solution. An inorganic non-aqueous solvent is a solvent other than water. That is, it is not an organic compound. Examples are liquid ammonia, liquid sulfur dioxide, sulfuryl chloride, phosphoryl chloride, dinitrogen tetroxide, antimony trichloride, bromine pentafluoride, hydrogen fluoride, pure sulfuric acid, and other inorganic acids. These solvents are used in chemical research and industry for reactions. Now we can see the classification of non-aqueous solvents. Solvents can be classified into protonic and non-protonic solvents according to the availability of proton. The solvents from which protons can be derived are called protonic solvents. Example, water, sulfuric acid, liquid ammonia, hydrogen fluoride, etc. The solvents from which protons cannot be derived are called non-protonic solvents. Example, liquid sulfur dioxide, benzene, chloroform, etc. Now we can see the second type of classification, that is acidic, basic and amphiprotic solvents. The solvents which have a tendency to donate protons are acidic in nature. They are called acidic solvents. Example, acetic acid, hydrogen fluoride, etc. The solvents which have strong tendency to accept protons, they are basic in nature and therefore they are called basic or protophilic solvents. Examples are liquid ammonia, pyridine, etc. The solvents which neither have a tendency to gain or to lose electrons or protons are called amphiprotic or amphoteric solvents. Example, water, ethanol, etc. Now the third classification is ionizing and non-ionizing solvents. The solvents which are capable of undergoing self-ionization. Self-ionization means auto-ionization. They are called ionizing solvents. Example, water, liquid ammonia, liquid sulfur dioxide, etc. H2O undergo ionization to produce hydronium ion and hydroxyl ion. Ammonia undergo auto-ionization to produce ammonium ion and amide ion. Similarly, SO2 undergo auto-ionization to produce SO2 plus ion and SO32 minus ion, etc. So that is, they undergo ionization. The second type is the solvent which do not undergo ionization. They are called non-ionizing solvents. Example, benzene, hydrocarbons, etc. Basically, they are non-polar substances. The fourth type of classification is coordinating and non-coordinating solvents. The solvents which are capable of coordinating with the metal ion or anions of the solute are called coordinating solvents. Example, ammonia, sulfur dioxide, dimethyl sulfoxide, dimethyl formamide, etc. On the other hand, the solvents which are not capable of coordination with metal ions, they are called non-coordinating solvents. Example, carbon tetrachloride, saturated hydrocarbons, etc. Now, the solvent property depends upon the physical parameters like melting and boiling point, dielectric constant, viscosity, dipole moment, heat of fusion, and heat of vaporization. Now we can see the first non-aqueous solvent that we have to study, that is liquid ammonia. The physical properties of liquid ammonia: freezing point is minus 77.7 degree, boiling point is minus 33.38. That means its liquid range is between minus 77 degree to minus 33 degrees Celsius. Dielectric constant vary between 22 to 28 at minus 33.5 degrees Celsius. The heat of fusion is 0.018 kilojoule per mole. Heat of vaporization is 23.6 kilojoule per mole. It is self-ionizable and it is acting as a associated solvent. Now, why ammonia is acting as a better solvent? It is because it is a poor conductor of electricity. Specific heat of ammonia is greater than water. It is less viscous than water. It has a high critical temperature and pressure. And the association through hydrogen bonding is less compared to water. And it has the property of self-reducing metal ammonia. When the liquid ammonia reacts with alkali metals, it forms strong reducing metal ammonia solutions. That is why liquid ammonia is acting as a better solvent than water.